Hello all. So today we will learn about the decision tree. And decision tree is one of the base algorithm. I say it's a base algorithm and you need to understand it very thoroughly because after decision tree, when we learn different ensemble techniques, bagging and boosting like random forest, ADA boost, gradient boosting, XG boost, everything is actually depending on the decision tree. So in depth, you should understand the decision tree algorithm. You need to understand those parameters also, those hyperparameters which are critical because when I will actually show you, I will show you the decision tree is a very good algorithm. But if you allow this tree to grow completely, then there is a high chance of overfitting. That's overfitting mean like when you are doing the training, you will get a good accuracy. But when you are doing the actual evaluation on unseen data or doing the testing, you might not get that kind of accuracy. So it can be low bias but high variance. So you need to understand how you will control those hyperparameters so that it will not be overfit. Okay. Some of you told me that why my videos are coming so late. Um, because I work in a company and I just do it whenever I have some time. Um, I'm trying my hard, so please bear with me, stay with me. Your support will help me to grow. Um, thank you so much. Okay, now jump to the course. Let's start decision tree algorithm. Okay, so let's start about the decision tree. So today, when we will explain the decision tree, but at the same time, first remember few terms actually because these are the key terms. One is called entropy, another is called Gini index, or in some books it's called impurity. And these two are used to measure purity split. I'll explain just right now because all these terms will be used so much. It's better to understand these terms at the very beginning. Another is information gain. Okay, these two terms will almost used very frequently when we'll explain decision tree. Now, for me, decision tree is nothing but a nested if else. Let's consider some kind of an example, like probably, okay, if salary, probably, let me write it, if salary less than equal to 1500K, print something like probably low salary. Else, if salary um, probably greater than 1500K and salary less than equal to, for example, 2500K, print medium salary, medium salary. Okay, and otherwise, else just print good salary. So this is a if else block. It's nothing but a if else block, right? If I consider this is nothing but a nested if else. This complete thing is nothing but a nested if else. This is in programming language, it's called nested if else. Okay. Now the same thing, if you draw as a tree, what will happen? This will be your first node where you will check, okay, if the person's salary is less than 1500K, or if yes, then it will be basically low salary. And if it is no, then it will be, it can be medium salary, it can be a good salary. So that's mean there will be another check, like if greater than 15K and less than equal to 25K. And then based on this check again, you will have yes and no. If it is yes, then it will be medium salary, and if it is no, then it is a good salary. Okay, so this is now a tree structure. Okay, so this is called the tree. And here few things is important to know. This is called root node, and this is called leaf node. Okay, so first understand this tree things. Okay, this is the way normally we build a tree, and nothing but a if else condition which is putting into a tree. Only thing, it's in a opposite direction. Like normally trees like this, right? Here it's a downward direction. Okay, good.
So now we will check how basically the split is happening when we build the decision tree. This is a very popular datasets available into Google, where it is saying a person will play tennis or not based on certain data points, like if it is sunny, if it is hot, humidity is high, windy is false, then person will not play tennis. Example was based on tennis. You can consider any game, whatever you like. So if we draw a decision tree, and assuming here that I will start my tree from the outlook. Okay, later we will define like how to basically choose whether it is outlook or temp or humidity. We will tell that, and for that you need to know the entropy, Gini index or Gini impurity, and information gain. So let's see how, like if we just do the split by outlook, how it looks like. So first of all, this is our first node by outlook, and right now here I have 1 2 3 4 5 6 7 8 9 yes, 9 yes and 5 no conditions. Okay, and then I will do the split by outlook. Okay, so we will possibly get three different conditions here. And how we'll get the condition here? If you check, we have sunny, overcast and rainy. So those are the three conditions. So this is sunny, this is overcast, and this is rain. Okay, so let's see. Now how many will go, like if we go only consider the sunny, forget about the damp, humidity, and windy for the time being. Just by sunny, if you check how many are yes and no, if you consider sunny, then we have total how many sunny points. Actually total we have 1 2 3 4 5 6 data point has sunny. 1 2 3 4 5 6. So in this case we will have 3y and 3n, because we have overcast condition. If it is a overcast condition, then how many yes and how many no are there? Overcast condition is 1 2 3 4, and we have only, sorry, I think I made a mistake. This should be 6y and 3n. And in the overcast condition, whenever there is overcast, yes, yes, so 1 2 3 4. So I have 4y and 0n. Okay. And when it is rainy condition, obviously it is saying some of the yes and some of the no. So let's count. So rainy, yes, yes, 1 2 3. So 3y and 2n. Okay, understand this split? Okay. Now again we will probably do the split by temperature, and it will continue like this. Okay, the important thing which I'm trying to show here, that is, let me change my color. This split, what is the impure split or what is the pure split? So look at this split here. I had 6y and 3n, right? So let's just first count whether we did it correctly or not. So 9 plus 5 is actually 14. So here 9 plus 4, 13. 13 plus 5, something we did wrong actually. Yes, what I did wrong. Uh, 1 2 3 4 5, 5 sunny condition out of that. Okay, okay, yeah, so let me change it. Actually, let's erase it, small eraser, and now it is clear. So when it is sunny, you see, when it is sunny, actually we have only one yes and two yes. Okay, so let's stick to that red color pen, and it is 2y and yes. So now basically it is matching, because here I have 5 split, 4 plus 5, so 40. Okay, now it's all right. Cool. So let's understand now. Again, let me check the black pen. So now check here. Here the split is proper split. Why it is a pure split? Because from this split I can easily say, when the condition is overcast, everybody says yes. So this is a pure split. Okay, but whereas this one is a impure split. Impure split, impure split. So this is the main thing. Okay, understand this up to this pure split and impure split. Okay, and how we will do calculate this impure split or pure split, that we have basically two things. One is called Gini index, one is called Gini index, and another is called entropy. Entropy. Okay, and also we will see how, because right now I started with the outlook, why not temp, why not humidity, that we will calculate by information gain. Whatever feature will give me the max information gain, I will select that feature as my starting point. Clear up to this? Okay. Now let's understand the mathematical intuition of entropy. Okay, let's start from here probably. Okay, so what is the mathematical entropy formula? Entropy, normally we write it like this, and probability of yes, and let's consider I am right now writing this formula based on the um, binary data, binary classification. Okay, minus probability of no log of base 2 probability of no. Okay, and consider here we are talking about, consider we are dealing with the binary classification. Okay, not related to this example, in general I'm talking about. Okay, so let's do some calculation. Suppose I have a tree where probably I have a feature and it's split at two child nodes. So this is one child node and this is another child node. And in the first condition, actual data, I have 9 data points, 6 yes, and after split I got, okay, 3y and 3n, and here I got 3y and 0n. Okay, so if we just put into this formula, what will happen? Okay, let's calculate the entropy. Entropy is telling us whether the split is pure and how much it's pure. Okay, entropy of C1. Entropy of C1 is basically, just by seeing I can see it's a complete impure split. Okay, so let's put it 3 by 6 because I'm talking about probability. So 3 by 6 out of 6, 3 is my yes out of 6, log 2 3 by 6 minus again 3 by 6 log 2 3 by 6. So if you do the calculation, it's coming as 1. Okay, clear? If you do this calculation, it will come as 1. Okay, I'm not going in that much detail, but this will come. And when it is 1, it is saying that it is a impure split. Cool. Okay, now we will consider the entropy of C2. Okay, let me just make some space here. Okay, where is my pen? Okay, so entropy of C2, entropy of, sorry, first we calculated C1. Okay, now C2. Just by seeing I can see this is a pure split, so expectation is I will get the value 0, but let's put into the formula. Okay, so what is my 3 by 3, because first I'm putting the log of 3 by 3 minus 0 by 3 log of 2 0 by 3. Okay, cool. Now if you put it into the formula, minus 1 log 2 1 minus 0, so basically I will get 1 is 0, so I will get the 0. Okay, so this is my pure split. Correct? Okay, you got it. Fantastic. So that's mean what we are understanding from this, like when we have a leaf node, so this is actually telling me when you have a leaf node, that's mean it will give you a pure split. also. Okay, and sorry, I don't say leaf node. This is for information gain actually. Pardon me. Okay, um, cool. Okay, so up to this it's clear. Now do one more thing. So that's mean what we understand, that if my is pure plate, then it's 0, and if it is impure split, that's mean it's 1. Impure split mean when my probability is half, 50-50. Okay, so if we draw this particular thing into um, 0 to 1, and this is my probability, and this is my entropy of any point, what will happen? So this is 1. So graph will look like this. When the probability is 0.5, the entropy is 1. This is the interesting ratio of this thing. Okay, clear? Fantastic. Now we will continue for Gini index. So let's consider now Gini index. Lot of books they are say index, and some of them called impurity. Okay, so what is the formula? Gini index formula is 1 minus to 1 n probability square. I'll probably just simplify it a little bit so that you can understand, because we are talking about again the binary classification right now. Binary classification. So let's write it a little bit of in a simpler way so that everybody can understand. So probability of yes whole square plus probability of no whole square. Okay, this is the formula. And again, if we calculate the same thing, like if we calculate, let me probably just change the color of my pen so that it will be easy to follow. So let's calculate now Gini of this two. Okay, okay. Uh, let's calculate. Okay, so G1 of C1. And what is C1? C1 is basically we have 3y 3n. So now if we have to calculate this, what will happen here? It will be 1 minus 3 by 6 whole square plus 3 by 6 whole square. So that's basically the Gini index or Gini impurity of C1, and it will give me 1 minus half, so it is 0.5. So again, what we are trying to understand, when we have the complete impure split, split, then the value is 0.5, whereas what we saw, that when the impure split for entropy, the value was 1. Clear up to this? Okay, and then again calculate Gini index of C2, and this is basically again 3 by 3 whole square plus 0, so it will give me 1 minus 1, which is 0, and this is my pure split. Okay, and 1 3 by 3, I think you understand right this, right? C1 is my this one, C2 is my this one. I'm calculating C2, and that's why we are talking about this one. Make sense? 3 by 3, because we are talking about yes, so we have only 3 data, and 3 yes, that's why 3 by 3. Okay, okay, cool. So then what is the conclusion from this, at least right now? the conclusion is, again, if you plot this into this graph, what will happen? The probability, the 0 0.5, when probability is 0 0.5, your graph will just go like this. So this is 0 0.5 and this is 1, and this graph is for Gini index and this is for entropy. Okay, clear? I hope it's clear to everyone. Now the question is, why two different kinds of mechanisms are available actually when we are doing the decision tree? Why we are not sticking with one thing? And this is a very big interview questions actually. Okay, this is interview question. What's the basic difference between these two things? Okay, let's understand that. Okay, when we are doing the entropy calculation, when we are doing the entropy calculation, our calculation is log based calculation. But when we are doing the Gini index or Gini impurity calculation, it's summation. It's just simple sum kind of calculation. So this is more time consuming. So this is more time consuming. Okay. And by default in sklearn, we are using this one. Okay. So this two, again, you can use as a hyperparameter, and you can find out which is the best. But in general, if you have a large data sets, if the data sets is very large, data set is large, then Gini performs better compared to entropy. Okay, that's a high level understanding. Hope you understand up to this, like how we are calculating the pure split and impure split, because this concept, this pure and impure split, we will next use. The next is basically the information gain, and we will use this concept into this information gain learning. Okay, so hope it's clear. Again, formula is this one, and if you have multi-class classification, just add more value like PA, PB, PC, something like this. I just try to make it very simple so that you can understand it. Again, entropy calculation, we showed like entropy of C1, entropy of C2 using the entropy formula, and then we calculate the Gini, and we presented the graph also, how it looks like, and also what's the basic difference, where is the runtime cost and everything is depending on. So that also we kind of explain. Okay, now we will talk about information gain, because this is the very important to understand. Because when you have multiple features, how we will decide that, okay, this is the feature I should choose at this moment. So let's start that discussion. Let's consider we have f1, f2, f3, three different features, and how, the question is how we will select the feature for root node and then next. Okay, and the answer is information gain. Whatever feature will give me the max information gain, that the feature is my starting point. That's a feature every time I will decide. So let's consider this f1 feature. First I'll consider f1 feature, and it's probably split C1 and C2. So 9y by 5n, and here we have 6y 2n. Let's just assume this is okay. And next one is f2. We're considering f2, and this is another child node, another child node. Okay, now we are trying to decide, okay, which one is better. Let's first calculate the information gain. The formula of information gain is hs minus summation of, well, s of v divided by s h s v. Okay, so first what we'll do, we'll calculate the entropy of root node. So first we'll calculate the entropy of root node. Let me change the color for better understanding in this case. So this is the first calculation point, and what we'll do, we'll say using the same formula. So 9 by 14, because I have total 9 plus 14, yes, because I'm right now calculating the probability of yes, log of base 2, again probability of yes, which is 9 by 14, minus 5 by 14, because now probability of no, and then log 2, 5 by 14. Okay, and if I simplify it, we'll get it 0.94. Okay, I just already did it, that's why I'm not going in detail. Okay, I think I'll just keep this so that you can understand. Okay, next is, again we are calculating the entropy of C1, which is minus 6 by 8 log of 2, 6 by 8 minus 2 by 8 log of 2, 2 by 8. Okay, you kind of understand why it's 8, 6 by 8, because we are considering this one here. Okay, this one C1. Okay, so what it will come, it will come 0.81. If you solve, you can check that. And C2 will be 1, because it's a complete impure split, 3y and 3n. I think from this, you know, this is impure split, 3y 3n, so you can get 1, you get the value of 1. So now the gain of SF1 is 0.94, which is nothing but the, let me change the color, which is nothing but the entropy of the root node, entropy of the root node, entropy of the root node minus 8 by 14 into 0.81 plus 6 by 4, oops, 6 by 14 into 1, so it will come 0.049. Now from where this 8 by 14 is coming, 14 is basically the number of observations, the total number of observations, and 8 is basically how many are part of this one. So okay, so when we are considering that formula here, this formula S is basically total sample, and SV is the remaining in C1 and C2. So you will get this value 0.049. So that's the gain. If I That is the information gain of this. If I use this f1 as the feature, then the information gain is 0.049. And if I use the information gain of s by f2, let's assume, suppose this is just roughly 0.052. Same way, if we do the calculation, then we will select this one. We will select this F2 feature. This is very, very important because the information gain is high for this feature. Information gain is max for F2. And again, this is, I'm just assume, okay? I have not calculated this value, just assuming, just to show that, okay, suppose after calculation you find this, then you will select this one. You will not consider F1. So that's the way to select the particular node, and this is the way information gain will be calculated, and we'll get the right feature to use for the root node and then the subsequent node. Okay, so lot of things we covered. Please try to go through this video multiple times, because these are very critical to understand from the mathematical standpoint and from the uh, intuition point of view. So what we discussed, basically we first discussed entropy, we discussed then Gini index or Gini impurity, and then using this we calculated the information gain. And remember this, the max of the information gain, suppose we have multiple features like f1, f2, f3, the max information gain will be selected, and that is the starting point to build the root node and subsequent node. Like next node, when we'll do root node, you decided, and then you have only these two. Like suppose for the first root node you decided f2, it's done. Now you are here, right, in this, and you have to decide how we'll split it now. So then again you will do the calculation of f2 and sorry, f1 and f3, because f2 is already used, and probably you find the max of this one, and then we'll do the split like this way. Okay, I think I know this is a little longer video, but please try to follow this. A lot of informations we covered. We will touch base again in actual practical. Okay, thank you and have a blessed day. Stay in touch. If you like, please hit and subscribe. Thank you so much. Bye.